Yeah, comes on everyone. Did everyone try the homework problem? Any answers? Vihan forgot the homework problem. You tried? Forgot. I tried. Anyone got the answer for the first one? The minimum distance between cat and dog? Let's see. Now, again, like whatever steps we did last time, we will follow the same steps, except for few differences. So in the B part, we have the cat is running with speed u. This dog, which is chasing the cat, is also running with speed u. Eventually, what will happen? The dog will come somewhere here. The cat will come somewhere here. The cat is going with you. The dog is also going with you. Isn't it? Can the dog ever catch the cat? That means finally, this is your final distance or the minimum distance. The dog can't get closer than this. Make sense? So eventually, both the cat and the dog will come on the same line, and the dog is running behind the cat. Is this a scenario? Clear with this? So in the previous case, when v was greater than u, the dog would have caught the cat eventually. But in this scenario, the dog can never catch the cat. Great. Now, at any instant for the dog, if this was the velocity, this was angle theta, the horizontal component was v cos theta. So I can write like this. The horizontal distance traveled by cat minus horizontal distance by dog. The difference should be the x final. There is a final distance between the cat and the dog. In the previous problem, this x final used to be 0 because they're meeting, the final distance is 0. This is also u. This is u cos theta. Everything is same here. So the horizontal distance by the cat is speed of the cat into time. It is going with a constant speed in a straight line. But whereas the dog horizontal component is u cos theta dt, because theta is variable, the horizontal speed is not constant. This is equal to x final. This is your equation 1. So in the part A, the x final was 0. So ut became equal to v cos theta dt. Any doubts on this switch? Clear? Now the second part. If you remember how we did the second part, we stopped the cat. So we are going to study with respect to the cat. Means if you can sit on the cat head and look at the dog, what will you see? So this cat is going with speed u. This dog here is chasing the cat with the same speed u. This was theta, so this also is theta. So when you want to stop the cat, what you do? You subtract the cat velocity from everyone. So this is u cos theta and this is u sin theta. And how do you stop the cat? Put u cos theta backward. Put u cos theta backward. Put u sin theta this way. Put u sin theta this way. Now the cat will think, okay, I came to rest. But this stupid dog is coming towards me with the u minus u cos theta. And this way it is going with u sine theta. Now this time it can't catch, but the cat will think the dog is making something like this. It is going on a curve. That's what it will feel. Then, so which velocity is responsible? So this is your relative velocity. Right, which decreases. So this is the relative velocity along the line joining cat and dog, which is responsible for decreasing the distance. In the previous problem, this was v minus u cos theta. So minus of u minus u cos theta, minus because the distance is decreasing. This velocity is decreasing the distance is equal to x final displacement relative displacement. U minus u cos theta dt. This is x final minus initial distance is L. This is equation 2. Have a look at this. Right, next thing. There we got two equations. So we have ut minus integral u cos theta dt. That is your x final. That was equation 1. U minus u cos theta dt is x final minus L. So from here, get this integral u cos theta dt is nothing but ut minus x final. Dump it in this. This is minus u dt. U cos theta dt is x final minus L. Take this and put it here. This will be minus ut plus ut minus x final is equal to x final minus L. Ut goes off. You end up with 2x final is equal to L. X final is L by 2. So the final distance between the cat and the dog is this, L by 2. Make sense? That is how you do that.
So how do we know that the final distance is the minimum distance? Why can't it be before that?
Think about it. Initially, what is this distance? This is already L.
Yes, sir.
Right, and this guy is always traveling faster than the cat. Matlab, this distance comparison this is always big.
Okay, sir.
Getting it? So only thing you can be sure, like when they come to the same line, you can be sure at the minimum.
Okay, sir.
Yeah, what you're saying is true, but logically we have to figure out that way. You're saying why can't it be somewhere here, na?
Yes.
The mistake was that. The mistake is, see, if the dog was here, it is looking like this. The cat must have been already here. It is stretching, isn't it?
Yes, sir. So, sir, the speed u is more spread out along the vertical and horizontal.
Yeah.
Yes, sir.
Because anytime if you see, the cat is always ahead of the dog in the x coordinate.
Yes, sir.
Getting it? The more the y coordinate is decreasing, x coordinate will increase much faster. But if v is greater than u, and if I ask you minimum speed, then anyway they're touching each other. it would have been a different story, because here both the speeds are same. You can approximately guess like, boss, yeah, this would be the minimum, because
Yes.
both are running with the same speed. If this is decreasing, this will increase even faster. Clear with this?
Yes, sir.
This is how you can get the variations. You can play more actually. What if the cat and dog are accelerating? But okay, that's a Dave question for some other day. But there's still one more acceleration question here. The acceleration of the dog. This is really tough one actually. Even your seniors find it difficult, even when you're in 12th. Let's see how to do this thing. There's a way you should know this, but more about this initial acceleration of the dog thing, right? We will do it in more detail in circular motion. But for now, I'll give you a little idea there. Like I said, these questions, right, should have seen them once and you should know, this question ko aisa hi karna hai. At least I couldn't figure out a second way to do these things. Look at this thing, the third part. Now, the main idea here is whenever a particle is going with a constant speed and changing directions. So let's say if you have a particle going with v, look at this thing here. When the cat is here, when the cat is going like this, what is the dog doing exactly? The dog was initially looking at the cat here, so this was the velocity vector. The moment the cat turned a bit, the dog ka velocity vector also turned a bit. Now, did the dog ka speed change? Dog ka speed didn't change, only the dog ka direction changed. Speed of dog is constant, but direction changes. So now this is a bit of a theory. So that means whenever you have velocity here, v, let's say if this is your v initial, and if this is your v final, this would be a change in velocity, which is v final minus v initial. How did you get that? Triangle of vectors. V final is v initial plus delta v bar. Can you see this vector plus this vector is this vector, isn't it? The triangle of vectors. That means in this triangle, if this was v and this is also v, the change in velocity will be this hypotenuse. And if you take this angle to be very small, d theta, so that behaves like for small angles, when you are taking very for a small time, this thing kind of behaves like an arc. This line behaves like an arc. It basically becomes a circle of radius v, which is v d theta. So the change in velocity for small angles is v d theta. What is acceleration? Delta v by delta t, which is v d theta by dt. So whenever a body goes with constant speed, the acceleration is given by v into d theta by dt. Now, in small time dt, so let cat travel by distance dt. Travel in time dt. So this distance would be cat ka speed, which is u into dt. And this angle would be d theta. So this forms a small right angle triangle here. Again, you can treat this like a small arc. D theta, this is u dt, and this is L. I'm exaggerating this. So tan d theta will be u dt by L. For small angles, tan theta is approximately theta only. So d theta by dt will come out to be u by L. Therefore, the acceleration of the dog is v, velocity of the dog, into d theta by dt, which is u by l. So v u by l. So velocity of the speed of the dog into speed of the cat by length between them. This is your initial acceleration. So this right side ka theory you should know, meaning if you don't know this, you can't solve the problem. So you assume for a small change, the velocity vector will rotate by a small angle d theta. So this would be the change in velocity, this hypotenuse or that arc length, which is nothing but v into d theta, because both the vectors have same magnitude. This is v, this is also v. So this is like an arc length. You can assume it is an arc because the angle is very small. You want to use 2u sine theta by 2, yes, you can do that also. Same aega. If you use 2u sine theta by 2, for small angles, sine theta becomes theta by 2. So 2 will cancel, you get u theta. That's also not a bad idea. Do you remember that 2v sine theta by 2? When a particle is going in a circle, the change in speed is 2v sine theta by 2. That also works. You can say 2v sine theta by 2. For small angles, that will become 2v theta by 2, which is v theta. Same idea. Do you guys know that, right? Sine theta is theta for small angles. So if I give you sine 3 degrees, what is this? What? 3. Then first convert this into radians. Sine 3 pi by 180. Sine pi by 60. So this is approximately equal to pi by 60. Theta should be in radians. Don't say sine 3 degrees is 3. Sine ka value can't exceed 1. This is how you find the cat dog ka acceleration. Little complex, but we will discuss this again in more detail in circular motion. But I hope all got the idea. Main idea was this. If you don't know this part, you can't solve.
Sir, after getting d theta, what would we do?
यहाँ से theta निकाला ना?
हाँ.
Let's say cat is traveling a small dt में cat कितना travel करेगा? U dt. So this triangle का this is the opposite side. This is the adjacent side. I got tan theta from here. For small angles, tan theta is again theta. So by से d theta by dt आ गया है, substituted there.
Yes, sir.
All clear with this? That's how you do the cat and dog. Next one. Definitely give it a try again on your own. It's a pretty good one. Turning the page. This is also a pretty good one. 64 is another model. We have a triangle here, ABC. There are 3 particles on the vertices, ABC. So this particle A here is chasing B with speed U. B is chasing U with speed C, and this guy is chasing U with A, same speed. So they all are on an equilateral triangle. Side A. So ABC move with speed U. Such that Wojas, you're there? Something happened? Okay. Such that A chases B, B chases C, and C chases A. Now, what do you mean by chasing? Look at this thing. Now see, the moment B goes little forward here, the A is going like this. Now, because A took a turn, the C which is looking at A, C also will take a turn. Because C took a turn, the B which is looking at C will also take a turn. You're getting? This is like this now. If a bus is going like this and you have to chase the bus, how do you chase the bus? You run like this, isn't it? Just like the cat and dog. They're chasing each other. That means the next moment, if you join them, you'll get one more triangle like this. Next moment, what will happen? Again, A will chase here, B will chase here, C will chase here. This would be the triangle. So A, B, C are continuously chasing each other. This is how they would look. Here the directions are reversed. U is going this way, B is going this way, and C is going this way. You can see how it is chasing. The particles chase each other. And we can observe here by symmetry, because all three are equal triangle, all are going same way. By symmetry, we can observe A, B, and C always form an equilateral triangle. The three will, whenever you join them at any point of time, they'll always form an equilateral triangle, which is shrinking and rotating, which is becoming smaller also, which is rotating also. Which is shrinking and rotating. And finally, they meet at the centroid, again by symmetry. Just because it is an equilateral triangle and just because all are identical. Even if one of them has a speed difference, this thing will get messed up. Finally, they meet at the centroid. This is the analysis part. This is what is actually happening with the problem. So these things will just go round, 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 and finally meet at this point, the centroid. Is the story clear? Is everyone clear how they're chasing each other? Now the question. So the first question is, find the time when they meet. Find the distance traveled by A till they meet. Draw the path of A as seen by C. If you're standing on the particle C and if you look at A, how do you think the path will look like? Let's get this. This is again another important model where the particles chase each other. I hope the story is clear, everyone. How they're chasing, how they're moving, and all. So, right. How do we go ahead from here? Okay. So you know how to do. So let's do the remaining also, the C part. This is not the actual question, huh? The actual question will come in circular motion. That is the actual question. This is just like a starter. That would be the deadly one. How that would look, huh? Like for your seniors, so I did. Same question, okay. So there we actually try to find the path. We try to find with what speed it is rotating, and we try to find the angle it rotates. As it is going round, 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 we need to find that angle theta. This is the actual question. Meaning I modified it, but yeah. It's a question from HCV. I like the question, but I thought it was boring just to find the time when they meet. So I added something, then I added something. By circular motion, it became a monster. So it is fun. Even the cat and dog problem is an Erido problem. Which one? The first part. I added that accession of dog. I added that minimum distance between the cat and the dog. And that is how you do. You take something, modify it here and there, and make it a monster. How do we start? So let's see the analysis part. You will notice something. Now, when this triangle is like this is your centroid. Point A, point B, and point C. Now, this velocity is u. This angle is 30 degrees. This velocity is u. This angle is 30 degrees. This velocity is u. This angle is 30 degrees. So now, if you resolve the velocity into components, you will observe this is u cos 30, and the perpendicular component is u sin 30. Here also, if you resolve the components, you will see u cos 30, and this is u sin 30. Here also, if you resolve the components, you will see u sin 30 and a u cos 30. Did you notice all are looking same? Okay. After some time, the triangle would rotate and shrink. The triangle would become something like this. O will still remain the centroid. ABC have rotated a bit, but you will notice this is going with you and this angle is 30. This is going with you, this angle is 30. This is going with you, this angle is 30. If you look at the components, you will notice this is again u cos 30. This is u sin 30. U cos 30, u sin 30. U cos 30, u sin 30. Did you notice something? What are the two velocities doing? What is u cos 30 doing? U cos 30 is responsible for shrinking the triangle. The u cos 30s are bringing the triangle closer and closer, isn't it? The u cos 30 components are responsible for shrinking the triangle. They are making the triangle smaller and smaller. And they're actually responsible for meeting, for shrinking the triangle and for the points to meet. That is what u cos 30 is doing. What is u sin 30 doing? U sin 30s are rotating the triangle. If you look at this is moving like this is going like this. Can you see how it is rotating? The reason the triangle is rotating is because of sin 30 components. So both the components, they're playing their own roles. So this u sin 30 we will see in circular motion. For now, we are all interested in u cos 30. So you tell me who is responsible for meeting the, to meet this thing there? The u cos 30? Is this analysis making sense? No matter how much the triangle rotates, the components will always be u cos 30 towards the center and u sin 30 perpendicular. Everyone clear with this? Now, if you take the triangle O here, this is u. Now we have clearly seen here the u cos 30 is responsible for you to go from O to this thing. So if I take this point A, so what will be the time taken? the time taken will be the length A to O, because you're going from A to O, by velocity along A to O. If you have to go from A to O, then the velocity along A to O is responsible, isn't it? Now, what is A to O? In an equilateral triangle, the centroid divides in the ratio of 2:1. That means this length will be 2/3 of the height, and this length will be 1/3 of the height. Height is nothing but √3 A by 2, which is A by √3. So this would be A by √3, and velocity would be U cos 30. This would be A by √3, U cos 30 is √3 by 2. That would be 2A by 3U. That is the time when they meet. Now, even though the explanation looks pretty big, technically, if you ask me what we did, we just found this distance, this velocity, and we finished it, isn't it? Now, all that story I was talking from the last 10 minutes is to explain you, but end of the story is you just need to find the distance from the vertex to the centroid and take the velocity towards the centroid and divide them, and you get the time. The same thing, if you want distance traveled, distance is nothing but speed into time. Now, I know A is going in some weird way, but the speed is still constant. That would be U into 2A by 3U. This would be 2A by 3. So what is this exactly? So if you look at the path of A in the ground frame, this is a centroid. This is how A is going. So this 2A by 3 is the length of that spiral. So the total length of that spiral, the A is going, this is how it looks. If you want to draw for B, B also would look something like this. If you draw for C, C also would look something like this. That is how all three are chasing each other, meaning this was the path I was showing you. As they get closer and closer, they rotate faster and faster. Please have a look at the idea there. So that is the main idea there. There are two velocity components. One is taking you towards the centroid. So take that guy and take the distance from the centroid to the vertex and divide them, you get the time. Is the concept clear, everyone? Anyone not convinced with this, please ask me. Nikhil, Devansh, clear? Daksh, Arya, Adi? Clear? Ahana, Daksha, Jainil, Ishana, Surya? Great. Now, if you understood this thing, then tell me the answer for this thing. Suppose we have a square and four particles are chasing each other. This guy is going with you. This guy is going with you. Find the time when they meet. Four particles chasing each other. So it doesn't matter what shape I take, the technique is the same. What if six particles are chasing each other? The only thing for these kind of problems is the shape should be symmetrical, the speed should be identical. It's a regular hexagon side A. Find the time when they meet, both the cases. There, I showed you a triangle and I'm asking you these things. Find the time when the four particles in the square meet and time when the six particles in the hexagon meet. Try, I'll give you a minute. Hexagon, you get a decent answer only. Again, what was the idea? from the vertex to the center where they meet, take the distance and take the velocity in that direction and divide them. बस वही concept था और कुछ नहीं. All the story that I explained is just to tell you that one point. But I hope now everyone is getting how these things are working. Try. I'll show you the answer. Take a minute. Yeah, I think most of you are getting the first part. Get the hexagon also. Look at this thing for the square. So you want to go from A, they will meet at the center. This is O. You're going with U here, and this is 45. So this component would be U cos 45. So time will be the length A to O by U cos 45. It's an half diagonal, so A by root 2. U cos 45 is U by root 2, which is A by U. Easy. Same thing for the hexagon. This is A. Now A to O, the distance is A only. It's an equilateral triangle there. If this guy is going with you, this angle is 60. So this component is U cos 60. The time will be A by U cos 60. Cos 60 is half to A by U. Yep. Easy. I can give you any number of sides. Now you know how to do. Any doubts on this? How would this look though? This is how the square would have looked. The four particles are chasing each other like this. This is how the hexagon would have looked. Able to see how it is going? The hexagon, the six particles are chasing each other. It will always form an hexagon which is becoming smaller and rotating. This is how the trajectories would have looked. Any doubts on this square and hexagon? Now there's still a third part of the question. How does the path of A look as seen by C? That means we need to stop C. So we know A is going with U. This guy is going with U. So if you want to stop C, what we do with respect to C, take U this way, take U this way. So C will think, okay, I came to rest. But this person A now is going with the U this way and U this way, and this angle is 60. So if I resolve this into components, this would be U plus U cos 60, which is 3U by 2. And this is U sine 60, which is U root 3 by 2. So if you ask C what is happening, C will think the A is coming towards me with 3 by 2. And therefore, if you want to find the time, that would be the distance AC by 3U by 2. AC is nothing but the side of the square. So you'll get the same answer, time of flight, time to meet. This would give you the answer a little faster. Meaning the problem with this is you lose all the information. You don't know what is happening, what and all, you get the answer. And if you look at the trajectory here, this is what we'll see, think about it. There are two velocities here. One is getting you closer and one is making you rotate. you will see a spiral. As you get closer and closer, you'll rotate faster and faster. At any instant, this is how the velocity will look. The A ka velocity will be 3u by 2 towards the center. And this will be u root 3 by 2, which is making you rotate. So when you're here, this will be 3u by 2. And this will be u root 3 by 2. So the 3u by 2 is making you get closer and closer, but the u root 3 by 2 is making you rotate at the same time. What you'll get is a spiral like this. As it gets closer, it starts rotating more and more. This is the path of A as seen by C. That's an analysis with respect to the points. Clear with this? Clear. So that is about the particles chasing each other. So if you see in this thing, right, relative motion, Rainman, Rubberboard, those are okay, but the tougher parts of the questions are these ones. This one, the particles throwing from the building, minimum distance. The bus one is still fine. The cat and the dog one, these particles chasing each other. If you ask me, these three are the main two-dimensional relative motion questions. Clear? Rainman and Rubberboard are also fine, but let's see them. Now you'll not find them really that tough now. Idea is the same. So next thing is the Rainman problems. So Rainman or rain umbrella problems. So the idea here is so when a person is moving due to relative motion, he observes the rain falls at an angle rain falls at a different angle. This, right, it's a rainy season. You can observe this when you're going to the class or anywhere outside. When you're in a car, train, or anywhere in a bus, observe when the bus is at rest or the car is at rest. Let's say rain is falling like this. The moment your vehicle starts moving, you'll observe the rain will start actually bending. Ever observed it? If you have not, next time observe that. When you're in a moving vehicle, right, when the vehicle stops, look at the rain. When the vehicle starts moving, look at the rain. You'll observe literally the rain will bend. So why is this happening? Let me take a simple example. So let's say you're running on the road or walking on the road with speed V. And let's say the rain is falling vertically with speed U. The rain falls vertically. Now, if I ask you how is the rain falling, that means the main catch is this in the question. You always stop the man. So whenever you do rain problems, you always stop the man. So we stop the man. And how do you stop the man? You take the man ka velocity and subtract it from everyone. So we take the man ka velocity u backward, and this is u backward. Now this person will think, okay, I came to rest. No, but this rain is coming with u backward and v downward. So this person will think the rain is actually falling at an angle. And so this person also has to keep the umbrella like this. If it doesn't want to get wet, if you're running, you have to change your umbrella position. And if you take this angle to be alpha, alpha is the angle with the vertical, This also is alpha. And we know tan alpha is opposite side by adjacent side. So here the opposite side is u by v. And what will be the resultant? And he will think the rain is coming with the speed root over v square plus u square. Because both are perpendicular, you can directly take the resultant. That means you will start thinking, you will think the rain is hitting you with a speed of v square plus u square at an angle alpha. That is what the man thinks. So in reality, the rain is actually falling with v only. But it is your, meaning relative motion. You start thinking this is what is happening. Is this clear, everyone? This is what we do in relative motion, isn't it? This is what the person will start thinking. But if you ask me, this is the whole theory of Rainman. Main idea why till now, right? The confusion was if two particles A and B are moving, normally you had a choice. You can stop A or stop B. In Rainman problems, always stop the man. Got the idea? Let's see a question. Let's do some easy ones. So we have the man here. Let's say he's going with 10 meter per second. So this is V rain with respect to the ground, meaning actually rain is falling at this speed. Is also 10 meter per second. And let this angle be 30 degrees. So the simple question. So at what angle does the man see? What angle with respect to vertical he sees the rain? Let's get this. Right, Purvada. Try others. Let's see. स्पीड नहीं पूछा रहे, at what angle पूछा मैंने. So step one, same thing. Let's first divide the velocity into components. This guy is going with 10 meter per second. So the rain which is falling here with 10 meter per second, and this angle is 30 degrees. So this component would be 10 cos 30. This component would be 10 sin 30. So stop the man. So what we do, we add 10 backward. We add 10 backward. So the man will think, okay, I came to rest. And he will think this rain is going with 15 now, 10 plus 10 sine 30, and downward will be 5 root 3. So he will think the rain is falling like this. This angle is alpha. Tan alpha, opposite side 15 by 5 root 3, which is root 3, and alpha is 60 degrees. Now, if they ask you speed, then you square them and add them. I didn't ask you that, but let's say if I ask you, that is 15 square and 5 root 3 square, that is 225 and 75. That would have been 10 root 3 meters per second. So he will start thinking the rain is falling at a speed of 10 root 3 at an angle of 60 degrees with the vertical. So you have to be careful which angle I'm asking, vertical or horizontal. Easy? That's it. This is a simple thing. You just stop the man and then you see the velocities. Let's see one more. One more. We have the man here. Whose speed we don't know. The rain is falling like this. We'll write as VRG, meaning velocity of rain with respect to ground. It's 10 meter per second. This angle is 60 degrees. Find velocity of the man if, first question, he sees the rain falling vertically. You're getting rain is actually falling at 60, but you want to see rain is falling vertically. The B part, he sees the rain 45 degrees to the vertical, like this. You want to see the rain 45 degrees like this. This is how you want to 45 side on the left side, okay, not on the right. 45 matlab it could have been right or left, but I give you the diagram. Two questions. Give it a try. Now this thing I reversed it. Abhi angle de diya, I want to see the man ka speed. Try 2 minutes. Just give it a try. I'll get some water and come. Let's see. 5 minus 5. What do you mean by minus 5? It's going backward. Okay, try the second one also. Try. I'll give you a minute. Finish off them. It's easy only. It's not meaning the kind of problems we did. Train man is actually a joke. Let's see. Hmm. 5 plus 5 root 3. Let's see. So, same story. Let the man go with V. And this rain is falling with 10 at an angle 60, right? So let's divide that into components. That would be 10 cos 60 and 10 sin 60. Idea is the same. Stop the man. Let this be V and let this be V. So the man will come to rest. And he will think the rain is coming backward with V minus 5. And this is going with 5 root 3. Now ask yourself the first question. He wants to see the rain vertically. If you want to see the rain vertically, means there should be no horizontal component. To see the rain vertically, horizontal component should be 0. So me minus 5 is 0, so v is equal to 5. So if you run with 5 meter per second forward, like I assumed, the sign takes care of it. If by chance if you had assumed v backward, na, this will be v forward, then you would have got v plus 5 is 0. The signs would take care of it. So you can assume any direction for the man, it doesn't matter. And for the second part, you want to see the rain at what angle? 45, this is alpha. So tan alpha would be v minus 5 by 5 root 3. So you want tan 45, which is 1. So v is equal to 5 plus 5 root 3. Easy. Check, why did you get a minus sign? All clear with this? Easy. Let's see one more. This is 45 degrees. Now man is going like this with 10 root 2 meters per second. The rain is falling like this. V rain with respect to ground is 25 meters per second. And this angle is 37 degrees. Same thing. At what angle does he see the rain? Now here rain is also falling at angle. Man is also going at angle. answers? 30, 10 was 1 by 6, 10 was 6 by 9, 7. 30 नहीं आएगा रे प्रतीक, इतना अच्छा नंबर तो नहीं है. I get pretty weird. हाँ, 6 by 7 tan inverse 1 by 6, tan inverse minus 2 by 5. Okay. Don't take the minus signs, right? Meaning minus sign is simply what? Left or right, na? Keep it that way. Tan inverse 6 by 13. एक answer भी match नहीं हमारे gods. We have 2 tan inverse 2 by 5. So maybe that looks right. Tan inverse 2 by 3. So we have Ahana and Nikhil, both of you got 2 by 5. Two answers are there. Remaining all got different answers. So tan inverse 4 by 5. We have 3 tan inverse 2 by 5s now. Devansh also got one. Maybe that thing is coming more. Step 1, resolve the velocities into components. So this is 10 root 2 cos 45. Ten root 2 sine 45. This is 10. This is 10. This is 25 cos 37. Cos 37 is 4 by 5. That is 20. Maybe you guys goofed up cos 37 sine 37. 25 sine 37 is 3 by 5. This is 15. Stop the man. 10 this way, 10 this way, 10 this way, and 10 this way. The man thinks he is at rest. And he will think this guy is going 20 minus 10, 10 this way. And this is 25. So this is alpha that way. So alpha is on the right hand side, and that would be 10 by 25, 2 by 5. Please check where you guys goofed up. Yeah, it's 25. Yeah, na, dekh lo. I think I know. You guys must have goofed up the cos 37, or you must have taken some data wrong. I guess it's not a tough one. You just take the components and subtract them. Clear? Next one. Easy. So basically, that is the main idea of Rainman and all. So what I'll do right after the Rainman and Riverboat, after teaching the next class, I'll give you a small sheet on this, maybe 15-20 questions only on Rainman and Riverboat. So all models are this only. Anything complex also, they'll do this only. Stop the man and you see what is happening. Nothing more, you can play around with that. So the next one would be the Riverboat. Riverman or aeroplane wind problems. So what is the catch about this river? So when you say a river is flowing with speed u, What this means is, if you take an object and throw in the river, right? So if an object is dropped into the river, it will move with the velocity of the river. Basically, let's say the river is going with some 10 kilometers per hour. If I throw you there, you'll drift with 10 kilometers per hour. That is the meaning of this. Now, if you take a man here, so we say velocity of the man in still water, meaning if it is a swimming pool or if it's a lake where the river is not moving, water is not moving, the man with his own effort, he can swim with V. That's the meaning of still water. Now, if you take a person like this and you put him in a river, now what will happen? The river speed will add up. Meaning, think of like this. Let's say you're standing in a train is going with 40 kilometers per hour, and you can walk with 10 kilometers per hour. What will happen? You're actually going with 10 plus 40, isn't it? Your speed adds up. So if I give an example, so let's say we have a river here. This man can swim with, let's say, 4 kilometers per hour. And the river itself is going with 3 kilometers per hour. So if this guy, we have a case like this, we'll see later on, just an example. Let's say if this person decides to swim straight, then we will see, so this person with his own effort is trying to swim with 4. The river is pushing him with 3 this way. That means in reality, this guy won't go straight, he will actually go at an angle at 5 kilometers per hour. You're getting it? It will be a vector resultant. He himself is trying to go in the y direction, but the river is pushing in x direction. So resultant would be 5 at an angle. He won't be going straight. Is this clear, everyone? What does a river do? That's it. This is the main idea. Whenever you drop something into the river, it will have the same velocity as the river. On top of it, if you yourself can also go extra speed, that also will add up vectorially. Clear. Then, now in this, there are 4 cases. Case 1, man swims along or opposite to the river flow. So let's say river is going with you. The river is going with you. Let's say this person decides to swim with the river V, and this guy decides to study this thing V. So the velocity of the man, as seen from the ground. Now understand, this thing when you say relative motion here, what is this V exactly? This V is the velocity of the man with respect to water. With respect to water, meaning it's like this: you're sitting inside a train and you're walking inside the train. You're getting a train ka speed adds up. You don't subtract here. So this would be V plus U I cap. Your speed actually bumps up. And here, if you look at the velocity of the man with respect to the ground, assuming man is going faster, it will be V minus U I cap. If U is greater than V, you'll get a minus or minus plus, means man is going to the right. Is this making sense? Updrift and load, meaning, when you're going with the river and opposite to the river, your speed simply adds up and subtracts. I hope the concept is clear. Hmm. No. Let's say a question. Let's say you go to a mall and we have an escalator. Now, just because it's a river doesn't mean you always get a river crossing. And you're trying to walk on the escalator. So, when the person stands on the escalator, it takes time t1. Now, for some reason, the escalator is not working, so you decided to walk. So, when person walks on a stationary escalator, maybe there is some repair, it is not working, you decided to walk. Takes time t2. So, instead of river, we have an escalator here. There's only difference. Now, the question is find the time when he walks on a moving escalator. Let's say you're going to a movie and it is getting late. You start walking the escalator. It's like in the airport. Did you ever do this thing? Like, you are walking on a travelator. If you just stand on it, you'll go fast. But if you start walking on it, you'll go even faster. Find the time taken when he walks on a moving escalator. The answer will come in terms of t1, t2. Let's get this. Any answers? Yeah, most of you got it. Easy one. We did this in the foundation, if you remember. So what's the catch? So let the elevator go with V1. You're just standing on it. So the time taken T1 is the length of the elevator by V1. In the second case, you're going with V2. The time T2 is L by V2. In the third case, this guy is going with V1 and you're also walking with V2. So time T3 is L by V1 plus V2. So V1 is nothing but L by T1 L by T2. So we get T1, T2 by T1 plus T2. Easy. Next one. Any doubts on this? Right, Janil? Clear, na? Let's get this. This is a question from the Eredo. Here's the first question in the Eredo. He's a Russian author, so when they convert to that English, there's a little issue with the words. But let's see, give it a try for 2 minutes, and I'll show you. I'll explain you the question. What is happening if you still couldn't understand? It's a good book. We can start doing after maybe another 2 months. I'll give you the list of questions which you can do. And instead of doing the book like a exercise or something, maybe weekly, every week you can do 10 questions. That would be a better way to assimilate. It's not about, you do 100 questions in a day and you feel happy about it. That is bullshit. The thing is, it takes time. It takes time to absorb. When you're doing questions properly every day, daily basis, like at least 20, 25 questions, you're giving time to assimilate, to understand, and for the information to be useful. If you just sit, it is like, just sitting one day and eating a lot of food for 3 days. That doesn't work. So working on daily basis is more important. Let's try. Give it a try. Read it. Let's see. You understood. Understand. Why will the raft be stationary? So that's what I'm saying. If you take a wooden piece and drop in a river, will it be just stay there? Okay. Solved it or guessing it? Roja? Solved it?
Sir, solve किया.
अच्छा. I think we have one answer. Let's see what is happening with the scenario. I'll show you both in the ground frame and in the reverse frame, relative velocity. Now see the first thing, right? A motorboat is going downstream. So when you say motorboat, it is like a boat with an engine and all. So it can go with its own speed, right? Let's say motorboat is having some speed v, and here you dropped a raft. Raft is nothing but a wooden piece. The raft is something, a wooden plank. Which drifts with the speed of river. Now he's saying, so let's say if the river is going with you, so initially when you're going, the boat is going down. Because you have an engine also, it is going faster. And then somewhere after 1 hour, you take a turn. And then while coming back, now tell me one thing, while coming back, will the raft be at the same place? Raft won't be at the same place. Raft is also traveling. So he meets the raft somewhere here. Are you getting the scenario? The raft is continuously drifting. You took your boat, you went down, you took a turn, and you came back. And he's saying you met the raft at a distance of 6 kilometers. This was the information that was given. So you went down the river for 1 hour, then you came back, and then you met the raft 6 kilometers from the initial position. This position was A. I hope is the data clear, everyone. Now, if you try to do this in the normal ground frame, so let the river go with you. So this was point A. So initially your motor boat will go with the speed of V plus U because you're going down the river. So you'll go like this for 1 hour. So T is equal to 1 hour, you will take a turn. So this distance will be V plus U into 1 hour. Now after this, let's say after 1 hour, let the boat meet the raft after time T. Let the boat meet the raft after time T after taking the turn. At time T after taking the turn. Now understand here, because you're going in the reverse direction, now the boat will have a speed of V minus U. And this is where you met. So this distance will be V minus U into T. Is that making sense? So you went down for 1 hour, you came up with for time T. In this process, your wooden plank was traveling with the same speed U. It came and met here. So for how long did the raft travel? For how long did the raft travel? Raft traveled for 1 plus T now. It traveled for 1 hour plus the time T when it came back. So this distance will be U into 1 plus T. Is this making sense, everyone? Now we can clearly see this distance should be equal to this distance plus this distance. So V plus U, that is the while going down, should be equal to V minus U while coming up plus the distance of the raft Y equals 1 plus T. So this is V plus U. This is Vt minus Ut plus U plus Ut. Ut will cancel. U will cancel. We will get T is equal to 1 hour. But it is also given the raft is traveling for 6 kilometers down. That means U into 1 plus T is 6. And T is equal to 1. So the boat has traveled for 1 hour down and 1 hour up. Total, the boat traveled for 2 hours. This is how you do in the ground frame. Is this making sense, everyone? I just kept the data, I draw a diagram, you can see what is happening. But if I do in the river frame, you will see it is much faster. But please have a look at this first of all. I did nothing there. I just took distance, speed, and all that. It is just about drawing the diagram little carefully. And yeah, understanding the words was a little weird. It is, you would have figured out maybe. Yeah, I didn't get the U into 1 plus 2. How is that? Arre God, for how long did the raft travel? How long did the boat travel? How long did it take the boat to go down? No? How long did the boat go down? 1 hour, right? And then how long did it take to come up? We said let it be t, right? So the boat went down for 1 hour and up for time t. So for how long did the boat travel? 1 plus t. So during this entire time, what was that wooden plank doing? It is drifting downward with 1 plus t time, isn't it? Yes. Yeah. Now, if you do with respect to the river, it is much faster. If you do with respect to the river, meaning think about it. Let's say if you and I, someone throws you and I, both of us in a river. You will go with you, I will go with you. What will I think about you? You're just beside me. So, if you stop the river, it feels the wooden plank is at rest. It will feel the raft is not moving only. And it looks like this boat is simply going with V, isn't it? River ka speed won't add. So it will travel for 1 hour going down. Now again, since the river has stopped, while coming up, what will be the speed again? It will again come up with the same speed V. Now you tell me logically, if you're going with speed V, if it takes 1 hour to go, how long will it take to come back? Won't it take the same time to come back? So that will be 2 hours. Is that making sense? If it takes 1 hour to go down, it will take 1 hour to come back with respect to the river. That is what the river thinks. That means the total time of journey was 2 hours. Now, this might look a little weird. That's the reason I taught you the other method also. Now, how long did the raft travel? So the distance traveled by the raft is 6 kilometers. That was given. And the raft traveled for 6 hours. So U into 2 hours is 6. So the river car speed is 3 kilometers per hour. This is faster. But then it should click, if I stop the river, the raft won't move. The boat will just go with V and come back with V. But for some reason, this thing is not, some people, this is not that comfortable. Then this is always works. Little lengthy, but it makes sense. You understand what is happening. This looks like you did some black magic, but okay. Is this clear, everyone? Meaning simple logic. If you're going with speed V, if you take 1 hour to go down, you'll come back 1 hour because the river stopped. The boat will go with V and come back with V. Clear, everyone? So that is a few cases there. So next class when we catch up, we're going to do the remaining cases. We have case 2, 3, 4, where the river is flowing in different directions and all that stuff. So mostly next class we would wrap up this, man river problems. We will do aeroplane wind problems. What if there's an aeroplane? Then we'll do flag and wind problem. There are a few variations of this.